Hi everybody, we're on chapter 4, inferences about process quality. Let's see what we will learn here. Statistics and sampling distributions. Here it shows the population distribution, and we will take a sample that we form a histogram, just look like a normal distribution. So the average is divided by n, but the sigma square is divided by n minus 1. We may show it again. So this symbol means that the x's are distributed normally with average mu and the standard deviation sigma square over n. No, the variance, sorry, this part is variance, sigma square over n. There is F distribution. I think here there were chi-square and T distributions. Bernoulli distribution, Poisson distribution. And point estimation of a process parameter. What are the parameters of normal distribution? They are average mu and standard deviation sigma. Let's try to explain this part. Here, let's say that we have a production line and we're taking random samples. Taking the samples randomly is very important. It means that we don't have any system or any formula to select the items, but we're just selecting them randomly. Let's say that this is the first sample, this is the second sample, and this can be the third sample. So this is x1 bar, x2 bar, x3 bar. Now, what does the central limit theorem say? Central limit theorem. It says that no matter, let's write it maybe, no matter what the distribution of the production, when random samples of n are selected, the averages, like here, x1 bar, x2 bar, and going to xn bar, let's say, or xk bar, as when random samples of n are selected, the averages are distributed normally. This is a very useful theorem because this lets us use the normal distribution graph. So which lets us estimate the population average mu and standard deviation from the sample, from the selected sample. So for the sample, for example, in this one, point estimation of process parameters, let's write it, point estimation of process parameters. What do we mean? for the normal distribution, we mean the process parameters as mu, the average, and sigma square, the variance, or we can call it sigma standard deviation. How do we estimate them? We estimate them from the sample, which is S average of sample. X bar is the average of the sample, and S is the S square, let's say, sample variance, and S is the standard deviation of the sample. So for point estimation, we just say that X bar is the point estimation of mu, and S square is the point estimation of sigma square, and S is the point estimation of sigma. Actually, in production, we wouldn't like to make point estimations, but we would rather choose to give a confidence interval for determining the mean and the variance.